This is G481 Homework Booklet, question 31. We are shown two forces acting on an object, and also that there is a point O at a distance of x from the nearer of the two forces, and we also have the separation acting between them. First of all, we have to find the torque of the couple exerted on the object. We know this is a couple because these two forces are equal in size, opposite in direction, and separated by a distance. So the equation for torque is one of the forces, in this case 4 newtons, times the perpendicular distance between them, which is 0.03 meters. Notice we were given 3 centimetres, but because the answer space has got the unit Newton meters marked, I have converted this to 0.03 metres. So just multiplying gives us an answer of 0.12 Newton meters. Next we have to calculate the total moment of the two forces about the point O. Now, this force that is further away from O is going to give us a larger moment, and that is a clockwise moment. So it makes sense to say that the total moment will equal the clockwise moment, take away the anti-clockwise moment. Once again, we want to work in meters here for our distance, but you mustn't be put off by the unknown distance x. Just start setting out the calculation and the problem goes away. So clockwise moment, we have 4 newtons at a distance of x plus 0.03 meters. From that we subtract the anti-clockwise force multiplied by the unknown distance x. Now the problem of the x just disappears because we have 4x take away 4x. And that leaves us with 4 times 0.03 from this multiplication of the bracket. So we have an answer of 0.12. We were asked to state the significance of this value. Just looking back above shows that it actually equals the torque. Now, looking at the next part, we're just asked to state two conditions for an object to be in equilibrium. Two standard points to learn: the net or resultant force is 0 and the net moment is 0. And now to part C. We have a new situation now with a concrete paving slab shown. We know its mass is 45 kilograms and we know its dimensions. First of all, we just have to find the density of the concrete. So the equation, density is mass divided by volume, comes down first, and then substitution. So mass of 45 divided by the volume. And we notice that the density answer is expected in kilograms per metre cubed. These distances are all in meters, so having made that check, we can substitute the 3 values into the equation. And I'm sorry, I notice I have put 0.63 times, and looking now, that is actually a 0.05. So please correct that, but this answer is the right answer of 2.5 times 10 to the 3. Next, we have to look at the moments in this particular situation. We have the two forces acting on the slab. So a force here, F, which is holding the slab upwards, and here we have the weight, which would be acting to pull it downwards. We're told it's in equilibrium, and the question asks us to find the unknown force, F. We can do this by taking moments. This question has been helpful in telling us to take moments about the point P. It's also been helpful because the two distances shown in the diagram are perpendicular to the corresponding two forces. This isn't guaranteed, and you have to remember your definition of moment carefully. Force times perpendicular distance between the line of action of the force and the pivot. Had we, for example, been given this distance here along the line of the slab, you may have had to have also used an angle and trigonometry to find this. But for once, it's nice and straightforward. So in the anti-clockwise direction, we have the unknown force F times the distance 0.6. In the clockwise direction, we have the weight times the distance of 0.15. On the next line of the solution, we need to substitute in a value for the weight. So we use the equation W equals mg. The mass was 45 kilograms, and here we have the gravitational field strength, 9.81. Finally, rearranging to calculate the unknown force F. So finally, simply dividing by 0.6 leads to an answer of 110 newtons.